let's get into the beta decay. So beta decay is spontaneous ejection of a beta particle, which is an electron, so just fancy nuclear chemist lingo, by a neutron-rich nucleus. Okay, so this gets a little bit confusing because we talked about in this previous video how the alpha particles are mostly from heavy nuclides and those that are a large abundance of neutrons, which you can see the uranium-238 and the thorium-230. These also are known to undergo beta decay. So I'll say also heavy nuclides. Okay. And so what becomes kind of crazy in beta decay, and this gets into one of these weird things, technically in beta decay, a neutron spontaneously turns into a proton as well as an ejected electron. Okay, so that's really what's happening in beta decay. It's this neutron-rich nucleus, so it has too many neutrons, and because of that large number of neutrons, we see one of these neutrons spontaneously turning into a proton and ejecting an electron at the same time. So if you look at the way the mass numbers and atomic numbers all add up, it checks out. So for example, this neutron becomes 1, 1, 0, right? So 1 plus 0 is 1. But now this is where we use the -1 nomenclature for the electron, because now here we have 1 minus 1 equals 0. So that's how this checks out, okay? So we note that the mass number does not change. However, the atomic number does change. So we're gaining an extra proton. So for example, thorium-234 can also undergo beta decay, okay? And so when that happens, the mass number is not going to change, right? So 234 stays as 234. But now we note the atomic number has to increase by 1. So if we find our thorium here, element number 90, there it is, we recognize with the release of that beta particle, it's a 0 minus 1. So that means this 90 has to become 91. And we can see that that becomes protactinium, Pa. Okay. Another particle or another nuclide that's unknown to undergo beta decay, iodine-131. And so if we find iodine on here, that's way over here, element number 53. So you can see it's going to gain an extra proton, so it's going to become element 54. There it is, element 54, which is xenon. Okay? So there's another one that we showed earlier, which was carbon-14. So carbon-14 is known to undergo beta decay. And as we shall learn, this is how we do radiometric carbon dating, which we will talk about very soon. So the way I can put this together, I know that this is a beta emitter, so that becomes 0, -1, E. And then now the 14 has to remain. 0 plus 14 is 14. Okay. And then now that -1 from 6, so that has to become a 7. Okay, 7 minus 1 gives me 6. And so now I need to find element number 7, and there it is, it's nitrogen. Okay, and so that's the exact reaction I showed you earlier. Okay, so we'll talk about another decay mechanism in the next video.